have the pleasure of interviewing Maria Carolina Gallego Iradi, currently at Stanford University in the United States, after having studied marine biology, waste management systems masters, and a Ph.D. in genetics. She did that remarkable study where she found Alzheimer's-like changes in the brain of dolphins, which got her featured in selected media across the world, including the National Geographic in Italy, the Times, the Neuroscience News, Chicago Tribune, Los Angeles Times, CBS TV, and Newsweek. We have this tremendous opportunity to discuss with her about her own personal experience with dementia, as well as the work that she has done in dolphins. My pleasure to introduce to us all Maria Carolina Gallego Iradi. I hope you enjoy this as much as I have. At Stanford University, doing immunology and transcriptomics, as well as your background in neuroscience. An extremely broad background that you have.
Correct. So I have more the point of view to understand the research.
Perfect. Now, everybody listening, the first question that they would want to know is your own personal experience with dementia. Have you had any experience at all?
Yes. During my career in Venezuela, studying marine biology, basically, and chemical oceanography, I was thinking to enroll in a program of oceanographic geology. And then we discovered my grandmother from mom had Alzheimer's disease, and this changed my mind. I began to do some personal research about the disease, what was actually the Alzheimer's disease, the symptoms, because we didn't understand well her behavior. It was very strange for us and very difficult to accept it, actually.
Yeah.
It's very, very difficult. So changed my mind, and I enrolled in a program in Spain at University of Zaragoza to do my PhD in neurodegeneration related with Alzheimer's disease with a fellowship.
Right.
And it changed my life.
Wonderful. Now, before we go into that, what I'm curious about is when you were with your grandmother, how long did she have Alzheimer's for before she passed away?
Yeah, approximately more than 70, so it was a sporadic disease.
Yeah, but
I don't think it was a genetics because it was a normal age. So.
Yeah. No, what I mean is in terms of how many years did she have the symptoms for before she passed away?
When we discovered the symptoms was a bit late.
Yes.
Actually, she was very advanced in the disease.
Yes.
So, like, approximately after 8 years, she passed away.
Yes.
The problem with the disease is we discover sometimes too late.
Yes. Absolutely. Absolutely. The reason I ask that is that so many people are going through the process of being carers, and it's so difficult. And sometimes they don't, it's important for people to understand that even researchers have the personal experience, and that sometimes drives you forward.
Yes, and it's very difficult to accept because in the beginning you don't understand what is happening.
Yes.
It behaves strange, so you don't understand. And then when you have the answer, you don't accept it because it's difficult to accept it. And then it's difficult to live with this. It's very difficult and it's make your life very different and difficult, and you don't know how to manage the situation many times.
That's right. Yes, yes, absolutely. So, I mean, that then drove you forward. You went on to do your PhD in Spain, and you somehow were looking at dolphins. Now, how did that come about?
Well, in the beginning, we were working with animal models to understand the disease and trying to make some approaches to new therapeutics. So we were working with chicken embryo, with dogs. And then when I was doing this this research, I asked for myself, why not dolphins? Since I'm marine biologist. So let's do the research in parallel. Dogs and dolphins, in human, of course, as my
Yes.
positive control. And then I began to collect samples from different strandings in Spain.
I see. So what is different about the dolphins as opposed to most other animals? Are they different or are they about the same?
If you have a dolphin brain in front of you compared with a human, it's so close. It's very complex, very hyper expanded. And as everybody knows, dolphins are very intelligent. We cannot measure, of course, with the same test we have for human, but we can measure with another kind of techniques. And everybody knows the dolphins are very smart. And also, they need to process fast sounds for echolocation, sing fast, catch the prey fast, and they have social behavior. They have actually their own names. So they are very close to humans, and actually we don't know who are even higher than humans.
Wow, well, that's fascinating. Wow. And so in effect, what did you then see? So when you looked at the pathology of the
Yeah.
dolphins, what did you see?
Yes, after many samples, many processing, uh, I discovered amyloid plaques. I
Mhm.
discovered neurofibrillary tangles. I discovered a lot of loss of neurons,
Yeah,
inflammation, microglia infiltration.
yeah.
The same pathology we have in humans. And I also sequenced the genes related with Alzheimer's disease in human, which is the APP,
Yes.
A beta 40, A beta 42, which is a neurotoxic, and genes related with the processing of this APP. Remember the APP, for the people that doesn't know what is that, imagine a ribbon, and
Yes.
we have a scissor cutting the ribbon in 1 meter, 1 meter, 1 meter, but for some reason we cut 20 centimeters, too much, and everything is accumulating. All these pieces of ribbons are accumulating, and the body cannot eliminate as fast as they produce. So this is a kind of similarity. We have the APP. And I discovered a new isoform, which is the APP 749,
Yes.
in dolphins. And the other genes are 90%, 97% similar than human. So we can assume they have the same processing machine, they have the same genes, they have the same pathology. We
Yes.
cannot say they have Alzheimer because we cannot say that, but we can say that have the same pathology than humans.
That's an interesting point because what I have been finding is that we oftentimes don't differentiate between the neuropathology of dementia and the symptoms of dementia because just because there is neuropathology doesn't mean that you will have the symptoms. And I guess that's probably the same with dolphins as well.
Yes, and it's very difficult because it's wild animals, so it's very difficult to control that point.
Absolutely, that's a very good point. I am going to raise a question here that I've thought about in that the dolphin brain and the human brain, as you said, are so similar in terms of characteristics. And one of the only things that I found that was different between humans and other mammals, and I guess dolphins and other fish, was the fact that we biochemically form uric acid instead of another product called allantoin, which almost all other animals do and excrete it to get rid of ammonia. And I wondered whether or not this is a part of why we may be seeing this pattern of disease in humans and dolphins, because you don't see it in the same way with dogs or rats as well, do you?
When I was doing my PhD, I sequenced the same genes in dogs also, has exactly
Yeah.
the same, very close.
Mm.
I actually used the same antibodies and the same primers for sequencing human, dogs, and dolphin, and it works perfectly. And the similarity was extremely high.
Okay.
Yes, so I found amyloid plaques in dogs too.
Yeah, I
I
see.
different,
Interesting.
yeah,
And so
yes.
do dogs get dementia?
Actually, the dogs we used to test the pathology was dogs with 20 years old, 18-year-old.
Yes.
You can find it in my papers, actually. And they took it to the veterinary because they have the classical symptoms like human, the orientation, they didn't answer to you. It was look like a kind of dementia, but of course we cannot measure as a human.
Absolutely.
But that
Yes.
was
Yes.
the reason, actually, they had to sacrifice the animals at that time because it was they cannot continue because it was very, very difficult to live like that. So they sacrificed the dog. I obtained the brains and actually found amyloid plaques in the brain
Wow.
of those dogs. Yes, 20-year-old, 18-year-old.
Wow. And so, based on your experience with some of the environmental work, because we're seeing such an increase in dementia, do you think there are any potential environmental links?
It could be. It could be, but Alzheimer's disease is a multifactorial disease. You have to take this in consideration, but
Yes.
everybody knows that mercury, lead, zinc, cadmium affect deeply our brain, dolphin
Yes.
brain or animal brain.
Yes. 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 So, I guess the same processes that affect us will probably be affecting the animals as
Most
well.
probably, most
Yes.
probably, most probably. But in this case, I had a particular interest since, the dolphins come in pods together and they follow leaders. And I was thinking, why not can be another cause of stranding? Because everybody talk about the stranding because contamination, because of the sonar of the ship, but why no? Because of the dementia of the leader?
Yes.
I cannot prove it because we need too many samples and in good quality because this is another reason it's difficult to go to the beach and find a good quality brain uh, to check the histology.
Yes.
But why not? It could be another reason.
Absolutely. And so, based on the research, what do you think is the hope going forward? You know, a lot of people are very anxious about dementia, and we seem as though we're struggling to find answers. From your perspective, what do you think?
That's why I'm now inside transcriptomics and immunology. Personally, I think different diseases can have the same cause.
Mhm.
So, for that reason, the different disease can have one way to solve the problem. And the insights of genetics and understanding the genes and the microRNAs and the level of transcription, maybe we can find biomarkers that we don't know yet, and we
Yes,
can use those biomarkers to solve the problem, to have some therapeutics approach.
absolutely.
So
Mm,
this is the correct way.
abs-
And I think we are close. We are close to find the answer for this disease and for another diseases too.
It's a good point. Do you think that dementia will become a gateway disease? That once we find the answer for dementia, we may find the answer for multiple other diseases?
I think so. I think so. I think different dimensions maybe can be correlated. So most probably we will find the solution very soon.
Wow, that is tremendous. I'm going to ask you a personal question with regards to what your thoughts are on this. If you had to choose, because at the moment the prevalence of dementia is going so high across the world, would you prefer to be a carer or to have dementia?
Difficult question. But I have the best answer for you is cure the disease and we don't have the dementia, we don't have the patient, and we don't have the nurse or the carer.
Absolutely, that is a perfect answer. And is there any message that you'd want to leave to just the general public? Anything that you'd want to share to, I guess, give a bit of hope for the future?
Yes. If we want to find fast a solution, we have to work together.
Yes.
Everybody has to share the research with the other researchers. Don't try to go deep inside like a deep spiral
Yes.
yourself. You need to collaborate with other researchers, with engineers, with biologists, with chemists, with different fields in order to solve it. We have to open our minds.
Absolutely. That is tremendous. Thank you so much, Carolina. Really
Thank you.
appreciated this. And I'm sure everyone will like to hear those thoughts that you've just shared. Thank you very much.
Thank you for the opportunity to collaborate with you.